Okay, so finding our inverse from a table was pretty easy, where we just switch our x and our y around. We also are able to find inverse equations, and that is really helpful, um, as we'll see a few different places later on, especially as we move into our chapter 7. Seeing what a function is and its inverse is really, really helpful. Okay, we're going to find what is the inverse of y equals 5x squared plus 2. And I guess I'll call this example 2a, because I'll do a second example like this too if you want to see. But the inverse of y equals 5x squared plus 2. Remember, the biggest thing about our inverses that our x and our y switch. X and our y switch. So when I go to find my inverse equation here, that's what I'm really going to remember. The x and the y switch. That's actually our first step. The first thing we want to do. Switch our x and our y around. So literally where we see a y, we're going to put an x. Where we see an x, we're going to put a y. Everything else stays the same. Now, technically, this is the inverse. The x's and the y's are switched. But if you think about how your equation needs to look in order to type this into our calculator, we're always in the form y equals. And that's what we're going to do here. We want to be in the form y equals. So I need to get y by itself now. Switch the x and the y, get y by itself. And I'll write those steps out over here too. Switch the x and the y, solve for y. So in order to get y by itself, we start off by subtracting 2 from each side. Then I divide by 5. And once we're there, in order to get that y by itself, to undo that y squared power, we need to square root. So y equals, and don't forget, since we had to take the square root of both sides, it's plus or minus square root of x minus 2 over 5. And when we're solving inverse, when we're trying to find the inverse, I'm okay with you leaving your radicals like this. And having a radical in the denominator. Typically, we don't want to do that, especially when we're simplifying radicals. But when we're solving for our inverse like that, I'm okay. Like that. That's our answer.